Thank you for joining this automatically generated presentation. Feel free to pause the video at any time if I'm going too fast. But now, let's get started. We successfully imported, consolidated, and analyzed nearly 33.6 thousand rows along 46 dimensions in your table plant CO2 data on October 17, 2018. A selection of 3 key observations that provide an overview of your top priority dimension carbon emissions has been compiled into this brief report. Our key insight is that the average of carbon emissions can potentially be reduced from more than 31.3 down to almost 13.6, which is a 56.7% decrease, by implementing 4 measures. So let's have a look. To briefly recapitulate, the input file plant CO2 data on October 17, 2018.xlsx was successfully imported and found to contain one table with almost 33.6 thousand rows and 20 columns. The top priority dimensions for this analysis include columns carbon emissions, date time, and mixer mix performance. Data quality was not an issue while compiling this report. Now, diving into the data, we observe that carbon emissions by date time has no automatically discernible patterns. Looking at the details, let us investigate the distribution of carbon emissions. The histogram values of carbon emissions have a very strong logarithmic regression with an R-squared fit of 0.8. If we focus on the top and bottom quartiles, we see that 7 observations explain 96.9% of the top quartile values and 98.6% of the bottom quartile values in column carbon emissions, with precisions of 41% and 59.1% respectively. For example, over 7.3 thousand top quartile values coincide with drawing number 1 mineral temperature between 181 and 259, mixer load size greater than 1877, and mixer outlet temperature less than or equal to 180. Consequently, we suggest that the average of carbon emissions can potentially be reduced from more than 31.3 down to almost 13.6, which is a 56.7% decrease, by implementing 4 measures. For example, addressing future activities similar to the more than 7.3 thousand instances that coincide with drawing number 1 mineral temperature between 181 and 259, mixer load size greater than 1877, and mixer outlet temperature less than or equal to 180 has a potential impact on the average of carbon emissions of almost minus 13.9, which would be an improvement of over 44%. The full list of 4 measures to optimize carbon emissions is available for subsequent detailed review. If you have any questions regarding these results, please do not hesitate to contact us. Thank you for your attention.